The sixth reason why I do not believe in evolution is because there are barriers to hybridization. So the first question that comes up is, what is hybridization? Well, a hybrid from a standpoint of evolution is the offspring of two animals or plants of different breeds, varieties, species, genera, especially as produced through human manipulation for specific genetic characteristics. A more simplified definition for our discussion here is a hybrid is the offspring from two species. So let's take a look at one other definition, and that's the definition of a species. And we're going to skip the first definition and go down to the second one. The second one is the biology definition for species, and it says the major subdivision of a genus or subgenus regarded as the basic category of biological classification, composed of related individuals that resemble one another. Now listen very closely to the remainder of this definition. Are able to breed among themselves but are not able to breed with members of another species. So this definition tells us that that animals are only able to breed within their species. They're not able to breed outside of their species. However, as we just looked at the definition of hybrid, that's exactly what we're going to have. Is we're going to have animals which breed outside their species. So, does this prove evolution? No, I don't think so. I think what it proves is as we spoke earlier, is that, and one of the other reasons is that science has flaws. Science is fallible. And the means that they have of classifying and putting animals into species according to whether they can breed or not is flawed. It's fallible. It has problems. It has shortcomings. It doesn't prove evolution. The fact is, if they breed, they must be very, very closely related to one another. And the species things is just something that man has come up with as a science to try to categorize or classify the animals. So let's take a look at some of these hybrid type animals. And the first one we're going to take a look at is the mule or the henny, which is a cross between a horse and a donkey. If the horse involved was a female, and the donkey was the male, then the offspring, and if the offspring is a male, that male will be sterile. So he will be unable to continue the new hybrid species. If the offspring, however, is a female, this is rare, but it does happen, there is a 5% chance that the female can reproduce. So what you will have then in that 5% chance is that the female will have to mate again with either a horse or a donkey because the male is sterile. So the female has to mate with either a horse or a donkey. So the genetic makeup will then be go back more and more back into either the horse or the donkey, whatever they continue to mate with. In the case of the horse being a male and the donkey being a female, that offspring produced is called a henny. And once again, the male is sterile, is always sterile. And so he cannot continue to reproduce that type of species. The female, then, if she may or she may not be able to reproduce. But once again, the things that we said for the mule also apply for the henny. That is, she's got to go back and mate with either a horse or a donkey because the male was incapable of reproducing. So this hybridization long term does not have much chance of success. So let's look at another hybrid, and that would be the liger. The liger is a cross between a lion and a tiger. It has existed only in captivity. And in the case of the liger, the female can be mated to either a tiger or a lion. But once again, you can't have a liger and a liger because the male is sterile. So once again, if that female mates, she's got to mate with a lion or a tiger, and the genetic makeup is going to begin to recede back into whatever she mates with. So the long-term outlook for this hybrid species, once again, is not good. Now, in the case of the Holpen is a cross between a bottlenose dolphin as the female, and the pilot whale is the male. And what we know about that is that the female can produce offspring, but we do not know about the male because so few instances of this have ever happened. In the case of, I'm going to mispronounce this, but Kamalu, she gave birth to 2 calves, and it was at the Tokyo SeaWorld. One of those lived only for a few days. Now, if you have an animal that only lives for a few days, they're not going to be able to reproduce. The other lived for 9 years. However, this is not a improved by natural selection type species, because the typical life expectancy of a bottlenose dolphin is 25 years. So this is not an improvement, and indeed it is not as strong an animal as the original animal was, or species was. Scientists predicted that this hybridization would be sterile, but they were once again incorrect. So the next hybrid we're going to look at is the Peasley, and that is a cross between a polar bear and a brown bear, and the offspring are fertile. And so to that I would say that perhaps the categorizations of science that should have these bears both in the same species rather than in separate species to satisfy the definition that we saw earlier, the biology definition of a species. But this does occur in the wild, and it does occur in captivity. To me, I don't get too excited about it because it's pretty much the same thing to me as 2 different breeds of dogs mating and having offspring together. So it certainly doesn't, impress me as being a proof for the argument of evolution. And then we have the mating of an Asian elephant with an African elephant, and this only has occurred one time as far as we know of. It happened at the Chester Zoo in England, and the calf only lived for 10 days. So, and this would appear to me to be a very close type 2 species, and yet it produced an inferior calf. That calf only lived for 10 days. So if the evolutionist wants to use hybridization as an argument that evolution is viable, then the hybridizations that we're looking at here certainly does not carry much strength, much weight as an argument for evolution. So when you have hybridization, you will frequently have the offsprings are frequently sterile. They have much shorter life expectancies, which greatly reduces their chances of future generations reoccurring. Also, because animals are selective in nature, in some animals the male is the more selective. In other animals the female is more selective. But in all animals they tend to mate with other animals of their own kind. Another barrier to hybridization is that DNA incompatibility prevents the production of offspring in most cases where mating occurs outside of the species. So the laws of DNA say no to hybridization in most cases. And then the last barrier to hybridization we have is geography. Geography prevents some mating from occurring. Examples, the grizzly and the polar bear, which we saw earlier, are able to produce offspring, but their likelihood of being in the same geographical area is pretty slim.